Hello and welcome back to the lab. So today we're going to continue work on the HP 740B DC standard differential voltmeter. So let's go. So I wanted to go over some of the work that I've done on this instrument already. So I've removed the top cover and the inner guard shield I've removed from this instrument. And if we look down here, right here, um, here is where one of those mercury batteries was soldered in place, and it had, of course, it was completely dead because it was, 40 something years old. But also it was leaking and it caused a little bit of corrosion here. So I removed the battery, cleaned up the corrosion, and I've attached this external uh, battery holder to mount one of those lithium coin cell batteries. I attached it to the side of the inside of the chassis with some foam, double-sided foam tape, and wired it up to the location where the original mercury battery was located. I also changed out the value of this resistor to a 15 megohm resistor. Actually, that's what that is, a 15 megohm resistor, to compensate for the difference in voltage between the two. I did a little Ohm's law calculation, and that's what I came up with. I don't know if it's correct, but it seems to be. According to the math, it should be correct to put in a 15 megohm resistor there. Um, that would draw such a tiny amount of current that this battery should last for years and years and years. But even if it doesn't, it's easy enough to replace. So that's one of the things I did. Um, the other thing I did was the instrument has two photochoppers in it. One of the photochoppers is down here. If you take a look, this block here with those two circular things, that's one of the photochopper units, and the other one is over here, kind of in the dark, uh, but it's right there. See those two photochopper things? They both contain two Ne2U neon light bulbs, which were burnt out. They were completely black and not illuminating at all. So I replaced all four of those neon light bulbs. And now, when you turn the instrument on, probably can't see. I have to let me turn off the lights in the lab. Um, with all the lights turned off, if you look now, you can see that those neon lights are definitely illuminating. In fact, they're flashing at a specific frequency, right? That's how that works. And these four are also now illuminating, and they are also flashing at a specific frequency. So hopefully we have these photochoppers repaired, although I'm not positive. It kind of seems like there's something still wrong with those photochoppers. So that's what I've done so far. Oh, also there was a second mercury battery on the underside, which I have not yet replaced because it's only used for part of the alignment procedure. It's not used in normal operation. And so I didn't replace that battery yet. I removed the original battery and jumpered it out with a piece of wire to make it a 0 volt battery. I have to go in and replace that battery as well. In addition, on this board back here, which is the not that board, this one over here, this board here with the two trimmer pots on the top is the um, driver board for the neons in the photochoppers, and you have to replace two of those resistors to get the frequency of the modulation and demodulation, get the frequency of the flashing of the neons to get into spec. So I had to readjust those resistors because these trimmers that adjust that frequency were out of range all the way to one side, and you still couldn't get the frequency. So you have to replace some of those resistors with a different value. So I did a little calculation and came up with the correct value for those resistors and swapped those out as well. So now the photochoppers seem to be flashing at the correct frequency. The unit is still not working, so I have some more work to do. But that's what I've done so far. So I noticed that the 740B does not respond to any input voltage when I have it set to voltmeter mode or differential voltmeter mode. It acts as if there is no input signal connected whatsoever. So I wanted to make sure that because I had fabricated the input cable, that I didn't wire something incorrectly or have an open somewhere in the circuit. So I wanted to check for continuity from my input connector through the input cable assembly to this connection on this A9 board. Make sure I had continuity so that when I have signal here, I also have a signal here. And I do. So I measure continuity between this point at the input terminal and where the signal enters this A9 assembly, the very first components on the board. Now I noticed that they have this sort of weird input protection circuit on A9, where they use this photoresistor here, which is illuminated by an incandescent light bulb, and you energize that light bulb through this transistor here to allow continuity through that photoresistor to allow your input signal to pass through to the rest of the circuit. It's a very strange circuit. I don't know why they would use a photoresistor, sort of opto-isolator type situation here, but that's what they did back in 1967. Um, But so under normal operation, this light bulb should be illuminated, allowing the signal from your input connector to go through to the rest of the circuit. And in fact, that was not the case. This light bulb was not illuminated. So I actually measured across the light bulb, and turns out that it's open. This light bulb is open. So I have to find a replacement light bulb for this one. And the 740B is not particularly built for service. So let me show you what I had to do in order to get access to that light bulb. So in order to access that light bulb, I had to remove the side panel, the side casting here, and then I had to remove, all these screws have already been pulled out, so I'm just showing you the steps. And then I had to remove this inner casting, this inner guard shield off the left side of the instrument. And then the A9 assembly is this board back here. I had to remove the 4 screws that were holding the A9 assembly in place so that I could carefully lift up this board without breaking any of the wires because it's wired in. It's not using an edge connector or anything like that. And here is that little opto-isolator assembly with the photo resistor inside. And I had to disconnect the 2 screws holding this little circuit board in place to pull that out. And there, right there, see if I can zoom in maybe a little bit. Right here is the light bulb in question. And it does not light up. And in fact, if you measure it with an ohm meter, it is open. So I have to see if I have a replacement light bulb for that. And I think I do, because it looks very similar to light bulbs used in other Hewlett-Packard instruments of the same vintage. So guess what? I do in fact have a replacement light bulb for um, that that burnt out light bulb. Physically, they're exactly the same. And electrically, they're both 28 volts at 40 milliamps of current. And so this is an exact replacement for that one. So I'm going to solder this one in there. and put it back together and see what happens. All right, so I have a confession to make. I've already broken the number one rule in troubleshooting electronic circuits. Always check the power supplies first. After replacing DS2, the incandescent light bulb, I didn't put it back inside of its little enclosure because I wanted to see if it lit up now, and it very, very dimly lit up. And that's when I realized I never checked the power supplies to see if we had any correct voltages over here. Um, Negative 30 volt supply, which is an unregulated supply, only measured 22 volts. Something is pulling that one down. Also, the plus 10 volt supply over here only measured plus 9.4, and that is a regulated supply. It should be closer to 10 than that, I think. I'm pretty sure anyway. So I went back and checked all the power supplies, and we found some more problems. All right, so here's the power supply schematic. Well, one of them. There's probably others in this instrument for the high voltage supplies and so forth. But I found this capacitor, C5, on the A6 assembly. C5 was a high ESR and low value. It was a defective filter capacitor, that's this electrolytic. So I replaced it. It's one of these right here. Um, I also replaced its companion over here on the negative 10 volt power supply, even though it tested good because they're both the same capacitor. And if one's going to fail, more likely that another one will soon fail. I mean, I assume. And because I had several of these, I just dropped them in. So here on that assembly are the two capacitors I replaced on the A6 board. The rest of these capacitors checked out fine. All the semiconductors on this power supply board checked out okay. But we were having some trouble with the negative 30 volt rail, which is this unregulated supply right here. It was only reading 22 volts instead of 30. Now this filter capacitor on that, the bridge diodes all checked out okay. This filter capacitor is one of those chassis mounted cans, and it's very difficult to get to. So I'm going to have to work on that. It's really kind of hidden. I mean, the connections to it are kind of hidden under a couple of other assemblies, which are more difficult to remove. So I had to work on that. Took me like another half an hour just to get access to this capacitor, and have yet to check it to see if it's defective or not. But something is pulling down the negative 30 volt supply. It might be that cap. In fact, it's a good possibility that it's that cap, but it might be something else on another board. I'm not sure yet. Well, that capacitor C5 is this large can chassis mounted can capacitor right here, um, which seems easy enough to access, except that on the underside there's something else covering up the connections. Now on the underside of the instrument, that C5 capacitor, the connections to it are underneath this main assembly here, which is the inside this enclosure is where all the precision divider resistors are, that are really the heart of the precision standards of this instrument inside of this case. Um, in order to remove this, I had to, there's a few screws that hold it in place, but also I had to remove all of the knobs off the front panel. Um, so in order to pull the shafts out of this thing, so I can pull this assembly away from the underneath and get access to that capacitor. And even after doing all of that, I can still only barely see the base of that capacitor, and I'll be able to get access to it, but it's going to be difficult. Well, unfortunately, bad news. That capacitor tests fine. It's okay. Um, which is good news actually, because I didn't really want to have to replace that capacitor. But it means that the problem must be elsewhere, and I don't know exactly how to isolate the failure. It's going to take me a while to work on this. But in the meantime, I'm going to have to put it all back together again, which will take me a couple of hours right there. So let me get started on that. So clearly, this instrument has more problems than I originally anticipated, but not to worry. I will get them all figured out eventually, and we will get this instrument back up and running just like it did back in the 1960s. But that's going to have to do it for this episode. Will probably take several more episodes before I finally get all the kinks worked out and get this instrument repaired. But we're going to keep working at it. So thanks very much for watching. Stay tuned for future episodes of the HP740B repair, as well as other interesting videos of vintage test equipment. Thanks for watching.